Hello, everyone. Today I would like to present research that I did as a part of my training at the University of Amsterdam in book and paper conservation. It was in collaboration with the Dutch National Library, where I'm also currently employed, as well as private practice, and RCE, the Dutch Cultural Heritage Agency. So the cause for research was two manuscripts that the KB acquired a few years ago, that both displayed the same problem. They were both made around 1500, and they showed powdering gesso and flaking gold leaf, but none of the other pigments were affected, so it was only this. So the questions that the KB had was how to consolidate these, with which consolidant, at what concentration, how many applications are needed. So I started the research with a diagnostic phase. We looked at the materials that were present, so I took micro samples of the manuscripts. I took one sample of their manuscript from the white gesso, and I also found one single folio with gray gesso, so I also took a sample of that. On the left you can see the SEM images, and on the right the places where I took the samples. So the two white gesso samples both consisted of chalk and some various impurities, and the gray gesso consisted both of chalk and lead white, which we think was applied in two separate layers. You can see on the SEM image that the distribution of the chalk, which is a darker gray, and the lead white, which is a brighter white, is somewhat uneven. So if it were applied in one single layer, we would expect a more homogeneous distribution. So based on this information and based on my primary source research, I made mock-ups on which I could then test the consolidation methods. I used a paper substrate. This was for repeatability because parchment can't be standardized. So for the gesso, I created three different sections. I created a section with very loose chalk, with just a chalk stick with very little to no binder, to imitate the most powdery gesso observed in the KB manuscripts. I created a gesso which I applied wet with a little bit of glare. This I found from the primary Dutch sources that I read. And on top of some of the gesso, I applied gold leaf that I partially damaged as well. For the consolidation, I made my choice for the consolidants based on literature as well. So I chose gelatin and methyl cellulose. I chose Aerosol, which is a low viscosity type of methyl cellulose. These were both tested and stable and strong enough to consolidate powdery media according to the literature. And here you can see the concentrations that I used. We were wondering if the literature, it said 4 applications is enough for powdery pigments, but we were wondering if this is also the case for flaking gold leaf, since gold leaf is not permeable like a powdery pigment layer. So I tested 4 aerosol applications, 6 aerosol applications to see if this would be beneficial for gold leaf consolidation, as well as one set of 4 aerosol applications and an additional brush application. I did not find information in book and paper literature about the consolidation of gold leaf, but I did find an article from a wood conservator who was unable to successfully consolidate gold leaf with aerosols. So, and they found that direct brush application was the most successful. And also used the same distance for every mock-up that I consolidated. So these are the parameters that I tested, and I repeated each parameter 3 times to make sure that the results were dependable. For testing, usually in book and paper conservation, we use a soft brush to test if pigments need consolidation, but I wanted to standardize the testing methods more, so I referred to the Weismann protocol, in which paper dental points are used. So these are points that you can see on the bottom image. I dyed them black because my gesso was white, so I wanted to be visible. And these points can be used to tap or the media to see if it's moving, or they can be stroked across to see if there's transfer. This testing was done by my colleague, Pauline Rings, who was not told in advance which mock-up was consolidated with which consolidant. And after that, I also used a tape test, which is according to an ISO standard. So this is often used in wall paintings or panel paintings, for example, to test if there's any transfer. So for this, you just apply Scotch tape or transparent tape, and then you remove it, and you can see if there's any transfer to the tape. These are the results of the Weismann protocol. For the chalk and the gesso, we have 3 different categories. So we have acceptable transfer and unacceptable transfer. This is rather subjective, but the way we define this is unacceptable transfer is if we can also see moving particles, if there's really a lot of transfer to the dental points, and acceptable transfer was defined because we use a lot of abrasive forces that I hope no object will ever be exposed to, so a little bit of transfer was acceptable. You can see that the gesso appeared to be well consolidated with both consolidants, and 4 applications seem to be enough. The chalk was also well consolidated with 4 applications already. There's one set that I consolidated with slightly higher concentration of Aerosol, but this was likely too viscous, so I couldn't get it to mist anymore, so then I used lower concentration for the rest of my mock-ups. For the Goldleaf, you can see that 4 applications of gelatin already gave very good results. But 4 applications of Aerosol were insufficient, and there was still movement on the Goldleaf when we touched it with the paper points. So for that, we would recommend 4 applications of Aerosol and 1 brush application. These are the results of the tape test. So after removing the tape from the object, I transferred it to black paper, and then I could use these photos to calculate the amount of white transfer. The way I did it is just underneath the histogram in the photo imaging software, you can see the average whiteness of the image, and in this case, the average whiteness would be the average amount of white transfer, which I then turned into these graphs. At the top, you can see the chalk transfer. Both consolidants perform very well, with about 4 gelatin applications being about equal to 6 Aerosol applications. But when we get to the results for the gesso, you can see that Aerosol didn't perform well at all. Gelatin performs about the same for the gesso as the chalk, but Aerosol was not really attached to the substrate at all. So if you think back to the Weismann protocol, it appeared that Aerosol was capable of consolidating it, but here we see that it was not at all attached to the substrate, and it was likely that the consolidant only sat on the surface of the media. The reason why that is probably due to the pigment size. So we also took SEM images of the materials that I used to create the mock-ups. On the top, you can see the chalk that I used for the most powdery chalk, and then on the bottom, the champagne chalk that I used to create the wet gesso. And you can see from the pigment, the particle size, that the champagne chalk consists of much smaller particles. So what this means is also that there are much smaller pores between each particles, and it is difficult for viscous consolidants to penetrate into the media layer. I also compared them to the particle size of the KB manuscripts. And you can see that these particle sizes are much closer in size to the chalk, the Belgian chalk, rather than the champagne chalk. So it is important to consider when you're consolidating what kind of media you're dealing with, if they have rough pigment or very finely ground. And usually it's a case of modern pigments that are more finely ground than older pigments. For the Goldleaf, I used a slightly different method. So here I calculated the amount of Goldleaf left after the tape test. So here a high percentage would be a good result, but sadly the results were completely useless. I have 2 examples. So mock-up 5, which was considered very well attached with the Weismann protocol because it resisted very harsh abrasion, performed very poorly. But then mock-up 17, which visibly moved and was not at all attached, gave a much better result. So here we have to refer to the Weismann protocol for the examination of the results and just ignore these, I guess. So to conclude, chalk was well consolidated with either consolidant. This was the coarser pigment, and 4 applications were sufficient. For the gesso, Aerosol was unable to penetrate into the media layer because of the particle size, but photogelatin was able to consolidate it. The Goldleaf was also well attached to photogelatin, and it appeared to be well attached to 4 aerosol application, 1 brush application of Aerosol, but as we know, it is likely that the media layer underneath the gesso was not attached to the substrate. So here we have to question if it's really suitable to consolidate Goldleaf as well. I would need to test it again with a coarser pigment to see if it works. I would like to thank my co-authors, Pauline Rings from the KB, Leila Sauvage, who was my supervisor at the UvA, and also Ines van der Werf from the RCE, who conducted chemical analysis. If you have any questions, please reach out later, or you can also send me an email if you would like. Thank you for listening.